Welcome back to Further Solutions Academy. This video I'll be walking you on orthogonal vector. I think I've explained this, but not in details in one of our videos. But at this point, I will just be showing examples on orthogonal vector. Don't forget you are home with Further Solutions Academy. Make sure you share the video and subscribe. If you have not subscribed before, subscribe among your friends, among your classmates. Now, when we talk about orthogonal vectors, orthogonal vector is just like vector u and v. I've told you that to be a vector, you must to put something like this there. Are orthogonal to each other if u dot equals to what is 0. Once their dot product equals to 0, it means that particular vector is what? Orthogonal. But if it is not, it's not orthogonal. Now we have orthogonal, we have orthonormal. Now I will be working on orthogonal on this video, while later I'll be emphasizing on orthonormal and all those things. Now, okay, I don't have much to say here. Before now, let me try to expand. Let me just show, because on the last video I've explained this. Expand 3u1 plus 5u2, comma 4v1 minus 6v2. And the second one, I have 2u plus 3v and 5u minus 7u. This is v. Now, and the last part of it, which is number 3, I have norms of u minus 4u norm squared. That is what I want to work on. Now, let's see how this will be solved. Solution to this problem. Now, it's very, very simple. What I just need to do, I'm talking about what? You, please, before you watch this video, try as much as possible to watch the video before now. They are it's very, very important, because it will continue from where we stop. Now, V2. Now, this will just be equals to, whenever I have something like this, I will just, like the way we normally open brackets in mathematics. For instance, when I have, I have 3x plus 4y. Everybody is used to this, something like x plus y. Now, this is 3x squared plus what? I have 6xy plus what? Y squared. That is what we are doing here. Now, it means once I have something like this, it will also be equals to, I will move on to, I can say that what? This and this, 3u1 v1, 4v1 plus this times this, I have 3u1 minus 6v2 plus this times this, I have 5u1, 5u2, 4v1 plus this times this, I'll be having 5u2 minus 6v2. Now, by so doing this, I'll be having 12 u1 v1 and plus this one will be minus 18 u1 v2. This is a space, and also I'll be having plus 20 u2 v1, and this is plus, and lastly will be equals to 30 minus 30 u2 v2. Now, please, can you manage to see that there? Now, since I have that, don't forget what I told you about the scalar in the previous video, that when you have lambda of u1 v1 can also be equals to lambda of u1 v1. Please, I've told you this. Since that is the case, which is the property I stated when I was defining inner space. Now, it means I can say that what? 20 u1 v1 and 18 I have u1 v2, and also I can say that plus 20 I have u2 v1 and minus 30 v2 u2 v2. Now that is what I'm trying to talk about here. Now can you see what I'm talking about? This one and this one, since the symmetry property holds, what I say about symmetry property, that when you have u v can also be equals to vu. Now since that holds, now we cannot continue by saying that now since symmetry property holds, that it was clearly stated in the last video that this is equals to this. Since that is the case, it means this and this can be together, can be alike times, can be a friend to themselves. It means I'll be talking about 12 u1 v1. This one will be plus this and this will be this and this alike times. It means I'll be talking about plus 2 u1 v1, v2 minus 30 u2 v2. Now that is what minus 30, this is minus, sorry, minus is here. Now can you see that is what we can do? This and this is u, this is v. There's nothing, assuming you are having 12 v 11 and is in form of this, you can now say that this is same as what? 12 norms. 12 norms. This is equal to what? 12 norms. But since it's not given like that way, you can't say that. It means you have to stop there for that area. Now, I think I've done that. Look at the second one. I have this also. I have number 2. I have of 2v plus 3. Is it u and v? Okay, I think here is v. Let me put this one as v, and here will be u. Okay, thank you, Tumishi. Now, and I have this. I have 5v 7u. Now, what I then need to do here is that this is a comma. Don't forget that I will be having 2v and 5v plus this will be what? 2v and what? Minus 7u and plus this will be also will be 3u 5v and plus this will be 3u minus 7u. Now can you see that this times this I'll be having 10 vv rather vv plus here will be it will be minus 14 uv plus this one will be 15 uv and plus I'll be having minus 21 uu. Now that is what I was telling you then. Now, can you see that this is equals to, it means I'll be having of norms. Hope I'm not making mistake. Yes, not. I'm not making mistake. Now, before I even translate it in the form of norms, let me try to simplify further. And minus this and this will be plus uv, and minus this will be 21 u. Now, this I have v, I have vv, and I have uu. It means it will surely give me 10 norms of v plus uv minus 21 norms of what? U. That is all. That is what I will be given. And that is all you are going to be getting there. Now, the last part of it, which is the third one, I'm having, which is number 3, I'll be having 3u minus 4, is it u or v? 4v, this is v. Now, norm square. Can you see this? It's very, very simple also. What I need to have here is that when you are having something like this, just put at the back of your mind that this is also the same thing as, this can be given as double of 3u minus 4v of squared. Now, I think it's repeated, which I can say like this. Manage that, sorry about that. Now, it means if I should open this, I'll be having 9 u, and I'll be having, that'll be 20, that will be, will it be 21? This and this times this, that'll be 12. I think I'll be having 24. It will be minus 24 u v, and I'll be having plus 16 v v. Now, without stress, I cannot say that what 9 norms of u squared minus 24 u of, and I'll be having 16, that'll be plus 16 norms of v squared. That is all what I will be having. Now, with this, I think you can see how it's being done. I have some problems here that I need to show whether is what. Now, look at this particular problem. I have this something like this. Okay, I have something like this. Okay, now let's try to work on this particular area. Solution to this. So for you to know that it's orthogonal, the dot must be equal to what is 0. Now look at this. When you dot them together, it must have is 0. For instance, u dot v, which is 2, 3 minus 1, and minus 1, 3, 4. Now, let me relate with what you have learned, during your secondary school days or year 1 days, Now, I can easily write my u as 2i plus 3j minus what? K. That is my u. I can also write my v as minus I plus 3j plus 4k. Now, there won't be any problem. Now, if I'm to dot them together, u dot v, it means I'm talking about this times this, which is going to be minus 2 plus this times this, it will be plus 9 minus 4. 4. Now, okay, I think here is 5. Let me put this one as 5. Sorry for that. I think from the question here should be 5. Now, can you see that this is 5? Now, you can see that which it will be equals to 0. it means U dot V is orthogonal vector. Now it's orthogonal vector. Now let me try the other one. Look at this. I have the second one, which is U dot W. It means, what am I trying to do there is that U dot W, 5I plus 3J minus K with dot of W is 5I plus J minus 2K. Now that is what I'm talking about, which is going to be 25 plus, I'll be having 3 plus, which it will be 5, which I'll be having 30. U dot W equals to what? 30. Not U dot W is not equals to 0. Therefore, is not what? Is not ortho what? Orthogonal vector. Now, it can only be orthogonal vector because if and only if their dot equals to 0. Their dot equals to 0. Now, look at the last part, which is going to be U plus V bracket of dot W. Now, how do I get my UW? My U plus W, it means my U plus W will be equals to 5I plus 3J minus K plus minus I plus 3J plus 4K. 4K. Now, this and this will be 4I. This and this will be plus 6J. And this will be plus 3K. Now, can I have it U plus W, plus V rather, dot W? It means, what is my dot W? It means I'll be having 4I plus J plus 3K, and dot of my W will be equals to 5I, J, and K. Now, this and this will be 20. Will be 20 plus, this will be 6, and this will be minus 6, which is not equals to what? Is not equals to 0. Therefore, U plus is not equals to 0 is not orthogonal vector. Now that is what we are trying to work on now. Okay, how I wish I can talk about orthogonal set. Orthogonal set and orthogonal basis. Tumiche, what is the time there? Okay, now. Okay, thank you, 540. Now, when you have something like this, how do I work on the orthogonal? Now, for you to know that something is orthogonal set, you must declare a non-empty set, which it can be what? U1, U2 to what? To UN. This is a set of numbers, and assume that a contradiction that the linearly dependent, they exist, that we have C1, C2, C to C of n. Yeah, these are scalar. Note, this can be a scalar. These are scalar. There must be a scalar. Now, since they are scalar, now when you now linear combination of them, when you do the linear combination, you will be having C1, U1 plus C2, V2, U2 rather, to Cn, Vn. Yes. That is linear combination of them. Since you have that, you can now generate, like, you now have attached to what? I can have C1, U1, U, plus C2 V2 U and dot C2 V2 and U. Now, if equals to 0 and equals to 0, please, because we are talking about orthogonal, you must be talking about the 0 part of it. Now, since you have it, I think I will now say that this is what is orthogonal set. I didn't have much. I am looking, for example, if it becomes basis, it means we can generate some metrics from it, which I will work on that some other time. But before I close this part, let me try to show another example on this regard. Okay, let's try to solve this. Maybe you can understand better on this part. Let me show you are making noise, please. Now, I have solution to this puzzle. What I just need to do here is that I want to know maybe the vectors are what? Orthogonal or not. What I just need to do, u dot u, which is going to be 1 and 2 will be, and u1 dot u3 and u2 dot u3. Now, anyone that is equals to 0 is orthogonal. But anyone that is not also equals to 0, it means it's or is not orthogonal. Now, the orthonormal is just like 1. I think I'll be working on that in the next video. Now, it means I'll be talking about 3, 1, 1 and minus 1, 2, 1. This time this, I have minus 3, I have 2, and I have what? Plus 1. Now, everything becomes 0. It means u1, u2 is what? Is orthogonal. Do you get what I'm saying now? Now, when I have the second one, which it means equals to 0. It does equals to 0. Now, the next one I have 2 and 3. 1 and 3, which is going to be 3, 1, 1, and dot of minus 1 all over 2, 2, 3 all over 2. How do I do this? This and this, 3 all over 2, minus and minus 2 and plus. This should be 0, right? Yes, it should be 0 because I have 4, that will be minus 7, which is going to be 0. Is 0. Now, it means u1, u2, u3 is orthogonal vector. Now, the last part of it, which is I have u2, u3, can it be equals to 0? What I just need to do, u2 minus 1, 2, 1, and dot of minus 2, 2, and 7 all over 2. Their dots, I will be having that minus 3 plus 4. It means minus, permit me to manage 1 all over 2 minus 4 and plus, which is not equals to 0. This u is can never be equal to 0 because I have this, that will be 8. Oh, is equals to 0. Is equals to 0. It means u is orthogonal vector. Now, that is what we need to do there. Now, another process of questions, let me try to generate another one. Now, this one will take us to what is called orthogonal sets and bases. But let me try to express, look at this, express, these are problems that express y equals to 6, 1, 8, 8 is having minus, in u1, u2, and u3, which is my let u1 equals to 3, 1, 1, u2 equals to minus 1 to 1 all over 2, and u3 equals to 1 all over 2 minus 2, 7 all over 2. Now, for you to solve this, what you just need to do is that you do this, you go this way by having y can be equals to y, u1, u2, no, u11, sorry, divided by u1 plus y u2 divided by u2, these are dots, u22 plus y u3 divided by what? u2 u. Now, when you have something like this, and you shall continue, don't forget that I cannot get my y dot u and y dot u2 and y dot u3. Whatever you have, I think y dot u1, according to what I got here, it will be 11. Here will be 2. And here will be minus 33. And the other one, u dot u, it will be 11. U2 dot u2 will be 6. u3 dot u3, it will be 3 all over 2. That is what we are going to have. Now, just need to, what I'm trying to do now, I'm working on orthogonal sets anyway. Now, it means my y, which is the set, will be equals to this and this will be 11, which is going to be u1 plus this one we have 2 and we have 6. It means I'll be having 2 all over 6 u2 plus minus, this will be minus 33 divided by 33 all over 2, which I will be moving it up time, which is going to be what? u3. This will be equals to u1 plus 1 all over 3 u2 minus, this will be 2 u3. That is the set I'm talking about. Can you see? This is a set of values that I'm talking about that are orthogonal. Now, I need to work on orthonormal, and also I need to work on orthogonal basis. I think before I talk about orthonormal, you must understand what is called basis of orthogonal. And because of our time, I'll be stopping here. Don't forget you are home with further solutions academy. Once again, help us to share and subscribe. I'm begging you. I know you have been doing well. Keep on doing that. Thanks so much for watching.